Hi and welcome to the course on Principles of Business Information Systems. Today, our chapter is about hardware, input, processing, output, and storage devices. The objectives and principles of this chapter is assembling an effective, efficient set of computer hardware devices requires understanding their role in supporting the underlying information systems and the needs of the organization. The computer hardware objectives are subordinate to but supportive of the information systems and the needs of the organization because whatever business we are in, the importance of hardware and the software plus the storage devices cannot be neglected. Whatever we do, we are storing our stuff on storage, we are using computers for input, we are getting the output in forms of printouts and other things. So that's why it's very important to understand different hardware which is used and they help in the information systems. When selecting computer hardware, you must consider the current and future needs of the information system and the organization. Your choice of hardware device should always allow for later improvements to meet evolving operational or the organizational needs. Now, whenever we are selecting any hardware, we'll have to focus and we'll have to calculate that this hardware would be good for the next 5 years or 4 years, depending on the growth on the hardware market or how fast the technology is changing. So you cannot keep the equipment over the longer period of time. Of course, you need to improve the systems, but there should be a provision where with minor modifications you can upgrade the overall performance and the output of the systems. Each computer processes its input through one or more central processing units, which we call it as CPUs, and the primary storage, which we use in terms of the hard drive on the computers. Then we have hardware for processing. Each computer processes its input through one or more central processing unit and the primary storage. Now, the central processing unit consists of three associated components. The first one is ALU, then we have control unit, and then we have registers. The arithmetic logic unit, which we call ALU as well, performs the mathematical calculation and makes the logical comparisons. Then we have the control unit, which sequentially accesses the program instructions, decodes them, and coordinates the flow of the data in and out of ALU. Registers, primary and the secondary storage are the various output devices. So the output devices for an ALU are the registers, primary and secondary storage in terms of getting the output of the system. Now the registers are the high-end storage areas used to temporarily hold small units of program instructions and data immediately before and during or after the execution by the CPU. So whatever calculation we are going to make, those set of instructions will be temporarily held in the CPU program, and once the data is processed, it would be executed and it will be released by the registers. As you can see in this picture that we have communication devices. First of all, we'll have an input and we'll have an output. Then we'll in the processing device, we'll have a control unit. We have an ALU, which is arithmetic logic unit, which registers the storage in the memory storage, which is primary and secondary. So once the input comes, the control unit and arithmetic logic unit would process the data. It would store it in the storage area, and if it's bigger than the storage area, or if it want to store it to the external media, it would send it to secondary storage. If it wants to keep it in the temporary storage, it would keep it over here. It would process the data and we get an output of it. Then we have the primary storage. Primary storage is the main storage which is there on the computer or on the memory, which provides the CPU with a working storage area for the program instructions and data. So in order to process a data, it needs to be stored somewhere on the computer. And since the primary storage main function is to keep the data over there for a short period of time, process it, and then give the output of it. The chief feature of the main memory is that it rapidly provides the data and instructions to the CPU. The main memory device contains thousands of circuits imprinted on a silicon chip. Each circuit is either conducting electrical current on or off, for example, known as binary or digits. The data is stored in the memory as the combination of on or off circuit states. Each character resembled by 8-bit. As you can see in this one, that if we have a byte, we abbreviate it by B, which is of 1 byte. If we call it a kilobyte, it's KB 2 raised to the power 10, which is approximately 1024 bytes. Exactly bytes is called a kibibyte. Now it goes on megabyte, gigabyte, terabyte, petabyte, and then exabyte. It depends how bigger is the storage device. Nowadays most of the hard drives are coming as in TBs, whereas in the storage we have the storage in petabyte and exabyte. So, in order to sum it up, we can understand it that during the execution of a data, it is usually divided into four steps. Step number one is it would fetch the instructions. The computer would read the next program instructions to be executed and any necessary data into the processor. Then we have the second stage, which we call a decode instructions. In the decoding instructions, the decoded data is passed to the appropriate processor for the execution unit. And then we have the third step, which is the execute instructions, that the hardware element now freshly fed with the instructions and data to carry out the instructions. And finally, in the fourth stage, we store the results and we send it to the registers, which are then saved to the memory to be executed. Now we calculate the time whenever we are calculating any kind of data on CPU. We have an execution time which we call an E time as well. That's the time taken to execute an instruction and store the results. And then we have another thing in this one, that when the complete instructions are fed to the CPU and the execution, that complete execution phase is called a machine cycle, because it's going from phase 1 to phase 2 to phase 3 and then phase 4. So all of this data which is being transferred and transformed from one stage to another is called a machine cycle. Then we have another term called pipelining, a form of a CPU operation in which multiple execution phases are performed in a single machine cycle, where all of them would be coming in a loop, and then it would go from the fetch state to the decode state, and then it would go to the ALU and store, and then finally it would go to the memory. So it keeps on revolving around in the same circle, where we have the first stage of fetch, the second stage is for the decode in the control unit, in the third we'll execute it and we'll calculate the E time for it, it's called ALU as well, and then finally we'll store it in the memory. Now, if we'll talk about secondary storage, the amount of the data that companies store digitally is increasing at the rate of the close to 100% per year, because there are lots of new devices through which we are collecting data for analytics and other things. Some of the data is being collected from the websites, the other is coming from the user statistics, then your web servers, and all those different kind of data that you want to feed on the computers and systems in order to perform certain calculations, predictive analysis. Then we have secondary storage. The amount of the data that companies store digitally is increasing at a rate of close to 100% per year, because we have lots of different devices these days. We have Internet of Things, we have databases, we have surveillance cameras, we have mobile phones, handheld devices. Now all that data is being stored in one way or the other in a central database which we use for different calculations. Sometimes the data is used in order to do some predictive analysis, sometimes overall behavior of the users and the statistics of the projected growth and other things, and all those calculations are being stored somewhere, so that we can use that data in order to perform these calculations. Now, the secondary storage is also called a permanent storage, that allows the organizations to store the large amount of data instructions more permanently than the main memory allows. Now, there is a small memory on the computer which is a local memory, and it comes in in different forms. For example, we have random access memory, which is the RAM on the hard drive. On the motherboard of the computer, you might have seen that you have 4 GB of RAM or 8 GB of RAM or 12 GB of RAM, depending what kind of a system it is. If it's a server or a workstation, of course it would have more RAM. A random access memory is a form of memory in which instructions or data can be temporarily stored within the memory, and once the calculation is done, then it is released from there. Then we have different kind of memories, because RAM comes in many varieties, like static random access memory, we call it SRAM. Then we have DRAM, then we have DDR3, SDRAM, all those different kinds. So your motherboard must support a specific kind of a RAM, and you must purchase the RAM according to the specifications of your motherboard. The latest computers usually have DDR3 or 4, which is the latest one. SDRAM used to be an older version of the RAM which was available on the older computers. Now, just like a RAM, we have a read-only memory as well, which is ROM. Now, ROM is a non-volatile form of a memory. It is non-volatile because its contents are not lost if the power is turned off or interrupted. It remains over there. Now, ROM is usually the data which is available on the ROM. You can find it in the BIOS of the computer or on the motherboard itself, where it is programmed to perform certain operations. Now, since it is read-only memory, it cannot be overwritten, but there is a new form of it which we call it electronically erasable programmable read-only memory, EEPROM, which is a user modifiable read-only memory that can be erased and reprogrammed repeatedly through the application or higher than a normal electrical voltage. Now, we sometimes upgrade the firmware of the computer, and whenever we are upgrading the firmware which is released by the vendor of the computer, usually that memory or when we are writing to that ROM, we use it EEPROM so that we can upgrade the firmware of the motherboard. Now, there's another kind of a cache memory which is there on the computer. It's a kind of a high speed memory that the processor can access more rapidly than the main memory. So it is used for the CPU to access it, perform its operations, and rest of the things would go to the main memory of the computer. Now, secondary storage is also called permanent storage, which allows the organization to store a large amount of data. Now, compared with the main memory, secondary storage offers the advantage of non-volatility, greater capacity, and greater economy. Now, since it is available in all different storage sizes, in different forms, you can store the data over the longer period of time for backup and lots of other purposes. So we have different kind of storage medium which you can see over here. We have magnetic tapes, we have magnetic disks, we have RAID, which is the redundant array of independent inexpensive disks. This is usually used in the servers when we want to have huge backup of the computers running, and we want the services to be working 24 hours a day. Suppose if you have a 10 terabyte of disk space, it would be divided into 5 or 6 different disks. Each disk would have the data or a parity of the other disk. So if one disk fails, the other two disks would combine and work together to build the disk which is failed once you'll replace it. So in that case, your data is not being lost. Now, in that way, whenever you are combining all those different disks, they are keeping parity of one on another. So all you need to do is, if a hard drive is failed, just remove that hard drive, put in a new drive, and these two healthy drives which are working, they will work together in order to build this second hard drive. Now, there are virtual tape, then we have optical disc, digital versatile disc, and then holographic disc, etc., and memory cards, which are usually used in the computers, mobile phones, and digital cameras. As you can see, this form of the magnetic disk was used for the backup that we use to maintain for the servers. We can store these disks over a longer period of time, but the only problem in this kind of disk is that electrostatic charge may affect the overall storage of it. We have these SD cards. They come in different sizes, micro SD card, SD card, or nano cards, because they come up with the storage which we can use on our mobile phones, on our digital cameras, etc. Yeah, they are quite handy. Then we have the normal magnetic discs, where we have a cylindrical disc in the hard drive, and it has a platter, splinter, head, accurator arm, and accurator axis, which is reading the data, and the accurator itself, through which we read and write the data on the disk. And this is the RAID level 0 or 1, or we have RAID level 0, 1, 5, 10, and so on. RAID level 0 is there, which is stripped. Then we have RAID level 1 as well, which is mirroring. So in case of a mirroring, if you have two different hard drives, the data of block A would be written to another block A. So if one hard disk fails, for example disk 2 fails, you can still have a complete data of it on disk number 1, and vice versa. That's how we maintain the integrity of the data. Then we have these older form of CD-ROMs. Then we had the DVD-ROM and Blu-ray. Different kind of hard drive, different kind of disks were there, through which we used to store the data on the storage disks. Now, next we have enterprise storage options. But before moving to enterprise storage options, we must understand what is a parallel computing. Now, parallel computing is a simultaneous execution of the same task on multiple processors to obtain the results. Now, systems with thousands of such processors are known as massive parallel processing systems, a form of multiprocessing that spreads the processing by linking hundreds and thousands of processors to operate at the same time or parallel, with each processor having its own bus, memory, disk, copy of operating system, and applications. The processors might communicate with one another to coordinate when executing a computer program, or they might run independently on one another but under the direction of another processor that distributes the work to the other processors and collect their results. So we are using different CPUs altogether. We divide the tasks separately in between them, and then once there is an output, we'll combine it all together and we get an output. But there is another kind of a computational power which we call a grid computing. A grid computer is the use of collection of computers often owned by multiple individuals or organizations to work in coordinated manner to solve a common problem. Now, grid computing is a low-cost approach for parallel computing. The grid can include dozens or hundreds or even thousands of computers that run collectively to solve extremely large processing problem. You might have seen this thing in blockchain as well these days, when all of those different computers are constantly processing it, they are trying to come up with an algorithm. The key to success for a computing is a central server that acts like a grid leader to and traffic monitor as well, which is collecting the data from the different computers, combining it together in order to come up with a final output of the computers itself. Now we have enterprise storage options. It has attached storage, the devices discussed before, attached to a single computer. For example, we'll have different kind of storage for SAN or NAS storage that we have mostly on the network, through which we are using the roaming profiles and other storage for the members of the group. Then we have network storage devices attached to the network. Then storage area network, similar to a network attached storage, except there is a dedicated special purpose high speed network that provides direct connections between the data storage devices and the computers across the entire enterprise. Now we have storage if we want to, for example, store the surveillance cameras data on these storage devices. Then we have the storage if we want to create the backup of the servers which are running on the network. And then we have a huge storage for the enterprise where everyone in the organization will be able to store their data. That data can include the data from the servers, that data can include the data from the databases, and the data which is available on individual computers as well. Now there are different attached storage medium available, as this one. This is a very small NAS, network attached storage, which is used for the backup, and you can see different hard drives, small hard drives in this one. Whereas on the network appliances, we have huge devices where we have the scalability option, that will have the base for the storage of the hard drives, but maybe if we are not using it, we can expand the capacity of it anytime whenever we want to do that. Now those kind of devices are usually called networks of attached storage. It comes in different sizes and capacities. Then we have the storage area network, as they discussed in the end, where lots of devices like computers, storage, disk, backup, servers, all those storages, they are all stored on a central location, which we use for the management of the data. Now, all of those storage are usually being controlled by the policy-based management programs, through which we make sure that the data of one user cannot be accessed by any other user on the network. Now that brings us the granular control on the user accounts, that which user has the access to which account. Just like in student accounts, if they are logging into the computers in the student labs, every student has an allocated space which they can store their data on. Now, if a second student comes and sits on that computer, he'll be able to see the data which was stored on his profile only, whereas he'll not have access to any of the other users who was sitting on that computer and have stored certain things on the computer. Now, all those storage area networks or network attached storage, we usually access it by an IP address. As you can see in this picture also, there is an IP address of this device. So if it's connected to the network, we can easily access it using its IP address. Now these storage devices comes from different vendors. You have from EMC, Dell EMC, you have HP storage, you have different vendors in the market through which you can get the huge storage devices. Now we have data input. Data input is input often requires transforming human readable data such as the sales records into computer systems. So whatever data you have received in terms of in the form of papers or documents or anything, it should be converted into a digital format which should be fed to the system. A human readable means that the data that people can read and understand. A sheet of paper containing inventory figures in an example of human readable data. So whatever data we have collected, for example, if you have received new stocks and you have noted down the details of the items that you have received, you can simply update the data using the Excel sheets, and that data would be fed to the computers. With the help of that, later you can generate the reports which would give you a complete idea of how many items are there in the storehouse and how many items have been sold. Now, machine-readable data such as barcode can be understood and read by the computer devices. As you might have seen at the point of sales in any of the hypermarts where you are buying any commodities, they simply scan the barcode on the devices, which would give the details about the item itself, its price, and rest of the details which are required for the billing purposes. So once it is calculating from there, it is updating the data in the main data sheets as well. So it's at the same time it is calculating the stocks which is available in the store and the items which has been sold as well. Getting the data in the computer system is a two-stage process. Human readable data is converted into machine readable in form of data entry. So once a user or a employee received the items at the storehouse, he'll note down the items, and then once he'll feed the data in the computer, through the data entry, it would be a computer readable data. Now, transforming the machine readable data into the system is the data input, just like we are reading the data or at the point of sale, we are getting or scanning the data from the barcode. Now, after that, we have data input devices. For example, we input the data through keyboard and mouse. We have speech recognition technology that it enables the computer equipment with the source of audio input, such as a microphone, to interpret the human speech as means of providing data instructions to the computer. You might have seen in Google as well, or on iPhones, Apple products, etc. You can communicate with the devices by the speech recognition technology. Even in the cars that we drive, we can give instructions by the audio messages and it can perform as per the instructions of the user. Now we have digital cameras as well. So the data from the digital cameras can be stored in the computers as well, because the data or the pictures that we are taking, they are usually quite heavy and we need a bigger storage in order to convert the pictures or to store it in the external or the internal storage media of the digital compute on the digital cameras or on the computers itself. Then we have terminals data as well. After that, we have scanning devices. Scanning devices could be anything like to capture the image or the correct or any character of the data. A page scanner is like a photocopier. You can either insert a page into the scanner or place it face down on the glass or the plate of the scanner, and it can scan it. We have different kind of scanners available in the market. Some are with the paper fed itself, some where you have to manually scan the papers and stuff. Then we have optical character readers. Now the optical mark recognition, OMR, such as the data is used on the multiple choice exams to detect the marks of the students and the page, and the optical character recognition, which we call OCR, which is read handwritten or typed characters. Now, OMR is a new kind of technique that we use in order to read the optical marks or the bubbles that you bubble on the bubble sheets in the exams. Through that, it would read your exam code and it would mark your papers. You don't have to go through individual questions and mark them individually, so it makes the life really easy. Then we have optical character recognition, where it would read the text from the scanned picture and it would convert it into a text which you can modify and later make any changes to the text itself. Then we have magnetic ink character recognition as well, which we call it as MICR devices used to read the magnetic ink found on the bottom of the bank checks. So you might have seen there is a small number and a barcode which appears at the footer of the check that you issue. Now that's a magnetic ink which is understood and read by special scanners. Now we have magnetic strips. For example, credit card input is by swiping the card through the reader. You might have seen at the back side of the card, you might have the magnetic strip, which includes the data about the user, its account details, and rest of the things which is related to the individual customer. Then we have chip and pin cards. We have contactless cards as well, where in contactless part it has an embedded chip that only needs to be held close to the terminal to cross the data. Now, in that case, there is usually no pin required, but in some cases you can set up the pin as well. But they are usually used at the point of sale devices. Now, point of sale devices are, for example, barcode reader or any of the cash counters that we see at the hypermarts, through which they are checking the items and their prices, and they are giving you a bill for that. Automated teller machines, which we call ATM as well, they are the special purpose input devices that bank customers use to perform withdrawal and other transactions with the bank and the other accounts. So you can use the ATMs in order to pay the bills, in order to withdraw cash, to transfer cash, and to deposit cash plus checks, etc. Then we have pen input devices. Data can be input by touching the screen with a pen input device or a tablet PC. For instance, you might have seen that most of the logistic companies are using these devices, that whenever they will deliver an item at your doorstep, they'll ask you to sign the PDA, and by that they'll send the confirmation that they have successfully delivered the item. Then we have touch sensitive screens, which we use on the in the offices or on the point of sales counters. Plus, you might have seen it at the fast food restaurants. We can use it in the organizations or in the educational institutions for teaching purposes as well, where we can touch the screen, and that screen acts just like a normal mouse which we are using on a computer. Now we have radio frequency identification. We call them RFIDs as well. A reader sends a radio signal which is picked up and returned by a tag. The reader recognizes the identifies tag. The London Oyster card uses RFID technology to let public transport passengers pay their fares. Now the passengers top up their card with the funds, and reader in the station takes payment of and built-in chip. Now, you might have seen that RFID tags are available at different places. They are all usually attached whenever you are buying something new for your family, or the clothes from the market. It has a RFID tag attached to it. There are multiple usage of it. One is it saves you from any kind of theft, that no one can take the items outside the shop unless and until they remove the RFID tag. RFID tags are used even for the refueling the cars. If you have a fleet of cars and they need to be refueled on daily basis, they can top up the RFID, and with the help of that, whenever the customer would go fuel to fill up its tanks, it would scan the RFID and would detect the money or the amount in terms of tokens or cash from those RFID tags which are attached to those devices. Now, like input devices, we have output devices. In output devices, we have display monitors. Now, display monitors are quite common these days. You might have seen at home. They are attached to the computers as well. Display monitor is a device similar to a TV screen that displays the output of the computer. Now, the latest kind of the display monitors, we call them liquid crystal displays, which are the LCDs in simple terms. There are lots of new names for it as the technology is evolving. Just like you might have heard plasma as well, LCD display are a flat display that uses liquid crystals in form of the characters for the graphical images and backlit screen. Then we have organic light emitting diodes. Now, these are used in small electronic devices. OLEDs use the same base technology like LCD with one key difference, whereas the LCD screens contain a fluorescent light, and the LCD acts as a shutter of the sensitivity to block that light. OLED is directly emitted light. Now, that's the latest technology after LCDs which is being used. Now, then we have printers and plotters. Just like the normal printers in the organizations where they are using the bigger posters, we print them using a device which we call a plotter. A printer is a normal device through which we print the A4 or A3 papers on our printers, but the bigger printing is usually takes place on the plotters. Now, the paper output remains one of the most popular and the most useful forms of output. Then we have digital audio player, which is the MP3 player or iPod, which is used in order to play the music. Nowadays, mostly these things are obsolete because people are using their mobile phones to play any kind of music from their devices. Now, computer-based navigation systems, which are the GPS systems, they are becoming more popular with drivers. Now we have the GPS on our mobile phones as well, but there are places where we don't have the signals from the cellular network, so we can use the dedicated GPS devices like Garmin and others, which helps the people who are into the off-roading or the drivers on the roads. They are heavily using the GPS system. Now, iBird screens and 3D printers are the specialist output devices through which they can print fully functional 3D models of the prototypes, whatever they have designed in their 3D Studio Max, or they are using SolidWorks or any software which is used for 3D modeling. Now, this is usually used in the prototyping a product. Whenever the engineers are coming up with an idea, they can develop a prototype or a fully functional working prototype of the device. Once it's fed to the system, it would print a complete fully functional working model of the same object. Finally, we have ebook readers. Ebook readers are the digital media equivalent of a conventional printed book. It is called a ebook or the electronic book as well. There are lots of electronic books available, especially on Amazon, where you can find Paperwhite, which uses the tiny LEDs at the bottom of the device that point towards the display. There are lots of them available in the market, so it is a very good thing if you want to store lots of books in one place rather than carrying all of them all together. You can save all of those books in a digital format in ebook readers. Then we have type of computer systems. In type of computer systems, we have handheld, also known as the pocket PCs, PDA, that are extremely mobile, multifunctional devices, just like this one, which, as I explained earlier, they are usually used by the logistics or the guys who are usually delivering the items at your home. Now, a smartphone, when a handheld computer, can also be used to make phone calls, or it's a smartphone. Note that there is no agreed definition on how smartphone has to be before it is classed as a smartphone. A smartphone is considered as these days as a device through which you can call, you can connect to the internet, you can update the information systems using the applications which are loaded on the devices itself. Now, portable computers are laptop or the tablet PCs. Mostly we have tablets or the laptops, but most of the places where they are collecting any sort of data for surveys and questionnaires, etc., they are using the tablets and getting the details of the users which is connected to the internet, and they can update the data through that. Now we have thin clients here as well, which are low cost. They have limited compatibility and performs only essential applications, so they can remain thin. And in terms of the client and applications, like this one, so it's a very small device which is usually connected at the back side of the monitor. This device does not have a very powerful CPU or a storage. It is connected to a central server which is located somewhere inside the organization. Now, the beauty of these systems is that since they are only the dumb terminals which are getting the feedback from the server and displaying the information on the screen, so there is no installation required on these thin clients. All the installation of the operating system, applications, each and everything is being fed by the central server, so they are just the players which are displaying all that information on the screen. They are low cost centrally managed computers with essential but limited capabilities and no external drives such as CD or DVD-ROM or expansion slots, etc. So since they don't have any storage, a bigger storage inside to store anything, they are just used for the portability and in order to expedite the process of installation and other things. Then we have desktop PCs. These are the traditional view what the computer looks like, just like you might have seen these computers which we use in the offices. Now we have workstations which are more powerful than desktop PC but essentially look the same. Just like this one black Dell computer is an office PC, whereas this big one can be a workstation as well. Now the difference between a normal PC and a workstation is a normal PC would be there, for example, Core i7 with 8 gigs of RAM or 16 gigs of RAM with SSD, etc. Whereas a workstation would have a Xeon processor, it would have 32 gigs of RAM and a GPU and lots of other things because they are dedicated for huge operations. After that, we have a thing which we call a server, just like this Dell EMC server. So talking of servers, they are used by many users to perform a specific task. Typically, they have a large memory and storage capacity along with faster and efficient communication abilities. Now, it can be used as a web server, an internet caching server, an enterprise server for Active Directory, file server, or email server, etc. So the normal server of a Dell would look like this one, which would be installed in the rack of the cabinet. Now we have another kind of servers which we call blade servers as well. It would come with a chassis like this one, and you'll have separate blades inside. Now these are the blade servers, and it would have a complete unified power and the network capability at the back end of it. So if we want to add more servers to this one, maybe these blades would be empty at this place. As you can see that this jacket is empty over here. If they want to add a server to this one, they'll simply slide in a blade which is called a blade server, and that would be used just like this server. Now these blade servers are a bit outdated technology. Nowadays we are using the servers like Dell EMC servers, which are quite robust, and they have lots of capabilities. After that we have mainframe computers. Now there is a difference between a mainframe computer like this one and a supercomputer. Now a mainframe computer is a large powerful computer shared by dozens or even hundreds of concurrent users connected to the machines over the network. Must be kept in a data center with a specifically controlled temperature, humidity, and dust levels, because it generates lots of heat. Since lots of CPUs and computers are working together, the more computational power, the more heat it generates. So that's why there is a temperature controlled environment where we maintain a specific temperature level in order to make sure that they are working at optimal, they are performing at optimal performance. Now after that we have to take care of the humidity as well as the dust as well, because those are the things which would deteriorate the overall performance of these mainframe computers. The role of the mainframe changing can be changing to a large information system processing and data storage utility for the organization, running jobs too large for other computers, storing files and databases too large to be stored elsewhere, and storing backups and the files in the databases created elsewhere, etc. So now these mainframe computers, they are a large powerful computer shared by dozens or even hundreds of concurrent users connected over the network. The mainframe computer must reside in a data center, and its cooling, usually we call it as HVAC equipment, which is used to maintain or to regulate the dust and the humidity, etc., inside the data center. Then we have supercomputers. These are the most powerful computers with the fastest processing speed and the highest performance. These are the special purpose machines designed for application that requires extensive and rapid computational capabilities. Before we used to use these mainframe computers, but now all these things has been converted to supercomputers. There are lots of supercomputers available in the world, released by different vendors. The beauty of the supercomputers is that they, first of all, their architecture. The second thing is that it employs the graphical processing unit as well. The graphical processing unit, which we call a GPU as well, is a specialized circuit that is very efficient in manipulating the computer graphics and is much faster than the CPU chip, and it performs the floating point operations and execution algorithms for which the processing of the large blocks of the data is done in parallel. So that's why supercomputers are becoming very successful. Of course, they are very expensive as compared to the mainframe computers. Now, there are different vendors for the supercomputers. IBM is being at the top. Then we have the Sunway NRCPC as well, which is the National Supercomputing Center, which is available in China. Now, selecting and upgrading a computer, for example, the hard drive considerations, that whenever you are selecting or updating a computer configuration, you'll have to consider the capacity, speed, media capabilities, and key features, etc. Today's business software and the large video and audio and graphic requires lots of storage. Now the hard disk is available in different forms as well. We have normal hard disk, we have nowadays SSDs available, then we have M2, and then we have NVMEs as well. So all of these hard drives have their own specifications. Some are meant to work 24 hours a day, some have a very high read and write speed. So it really depends that what kind of data you are dealing with, and according to that we buy or we decide that which kind of hard drive would be more suited. Now the NVMEs are the latest one which is available in the market. They are the fastest one. You feel a huge difference even if you are using it in the older computers. It rapidly changes the overall performance of the PC. Organizations are usually using it for databases and other things as well. Now main memory considerations are the RAM, which is required for the computer. If you are dealing with a computer which is dealing with the basic kind of data input and output, maybe you don't need that much of a RAM. But if you are running virtual machines and having databases and high computational processes on your computer, then you need to have a bigger RAM on the computer. Now, the printer considerations are major considerations are the price, color, speed, and toner as well. Because before buying the printer, we must decide or we must check the price of the toner, because that would be consumed very fast. And in order to refill it, sometimes the toner prices are way too high that it becomes really difficult to continue using that printer over a longer period of time. In most of the cases, when the printer price is low, you'll see that the toner prices are usually very high. Many companies now consider environmental issues as well as when selecting or upgrading. Then you'll have to decide that which documents and which things you really want to print, and print it only when it's really necessary or required. Now after that, that's the summary of the chapter where we talked about the hardware components, then we had the secondary storage, for example, magnetic disks, etc. In enterprise storage, we talked about NAS and SAN. Then we gave some examples of input devices like keyboard and mouse, and example of output devices like the LCDs, etc. And computer can be classified as a special purpose or a general computer. Then in computers, we have handheld computers, portable computers, desktop computers, workstations, and servers, etc.